Well, hello everybody and welcome back to another episode of this series. We try to write our own kernel from scratch. Last time we've reworked our GDT initialization, and today I want to take a look at the IDT. Yeah, so before we get to this, I've actually made some just slight changes to this code here. As you can see, I moved all the definitions and for GDT and the segment data types to their own module here. So I have this, I guess, global module under descriptors called type that basically has the types that are shared, and then I have the GDT module here with its logic in one place. Let's not get sidetracked too much. Let's go ahead, jump in right away and create an idt.zig module here. Think we are going to need stud, so import stud. I guess we are going to need segment, which is import types.zig .segment. There we go. And let's get right to it. So we are going to create this, or we are going to set the value for this IDTR or IDT register for interrupt descriptor table. And we want to, so basically the same as we did with the GDT, we'll have the base address for this table here that has all the info for interrupts, and then we have the size for that table. Now, the question is that this table here will have, so I think, yeah, there are only 256 interrupt vectors that are defined by CPU manufacturers for x64. We just need the IDT to be 256 descriptors long, but given that every descriptor is 16 bytes of size, that brings us to 16 times 256, which is one whole page. Cool. So that with that out of the way, we already have the structure for, I think, let me just check. Under types, under descriptor 16 bytes. Is this the same structure we are expecting for IDT? I think it is, but I'm just looking for the field names if they are the same. So yeah, I already see a difference for the field names. Okay. Okay, so let's not get too sidetracked. Here's what I'm going to do. I'm going to go up here. And I'm going to, yeah, sure, let me just rename this to be, I'll give them, so global table descriptor. Sure. This might break pretty much everything else, but it doesn't seem like it did. I'm pretty happy with that. Cool. So now that we have these, or rather this one here, I'm just going to quickly go ahead and, yeah, sure, pop const interrupt table descriptor, and this one would be a backed struct that's backed by a 128 U128. Okay, and let's take a look at what the, so offset segment selector, and then here we have 16 bytes for some data, and then the rest of the offset and the other offset. Cool. And of course we have reserved bytes up there. So we start with offset. Offset lower, sure. That's a 16, U16. Then we have segment selector. So this one here can become segment.selector, I think. Let me just take a look. Segment selector should be segment selector for destination code segment. And that's exactly what we have. And then here we are going to jump over these and go and define 16 bytes. Rather, hold on. I could put these into 16 plus 32. Yeah, I can do that. So basically brings us to do some, whoops, not what I wanted to do, but there we go. So this one goes offset upper, sure, and then we have some reserved UD2. I guess we can just copy that here. So very nice. Now let's go ahead and take a look at this. So we have IST. Are these defined anywhere here? Okay, cool. So bits 0 to 4 is used by the stack switching mechanisms. Okay, so here we should put these to 0 and then just take 3 bits. Because we have a number of ISTs, I think we can only have 7 of those. Let's take a look at how we define. Yeah, so here we have 7 of those ISTs, and we need 3 bits to IST. This one would be a U3. Yes, 3 bits to describe the IST. The IST, not the IST. And then we'll have, so the remaining 4 bits, 5 bits, I guess, of the byte. So I guess we could call those unused and have that as a U5 with a default value. And I'll just go ahead and do reserved with an underscore. Right, so after the unused, we have the type. Do they tell us about the type? The type field, so bytes 8 to 11, is described in table 3.2. Okay, so I guess LDT, we don't really care about LDT for now. And then we have TSS, we don't have those. So we can only have this value here, or this value here. And I'm pretty sure we are not going to use call gates, not the toothpaste, but call gates. Right, so that should be type, and this would be interrupt. How should we call this? Descriptor type. Right, so that means that we should go up here and do no. So this type here is okay. So this type here is the problematic bit. We should call this global descriptor type. Sure. Yeah, I'm just a bit riffing for a bit here. We'll see how far this takes us. But so interrupt descriptor. Hold on, what did I call the other one? Global descriptor. Yep, that looks okay. Until we have these two values in that. So these, and I guess they don't really have names. So I can just set them to 14 and 15. Yeah, as values. Okay, let's actually do that. Before we move on, let's just create. Where is the other type? There it is. Let's just create a pub const interrupt to rs1u descriptor type is an enum over a u4. Right, so this one is 4 bytes, and then we'll have other things next to it. So 4 bytes. Whoops. And we've said that we have something that's 14 and something that's a 15. And let me just go back and take those. Where is this table to? There we go. So interrupt gate and trap gate. And we'll get to the differences interrupt gate between those two when we actually work on interrupts. For now, we are just going to lay down the groundwork for that. So trap gate. Sure. I'm actually tempted to call this so hold on. So this one is a global descriptor type. This one is a descriptor type. I'm tempted to call this segment access type, or just segment type. Okay. And I'm tempted to call this just gate type. Okay. Right, so after type, we should go back to section 6, interrupt handling. There we go. No, a bit far. 6.5, 11. There we go. Maybe a bit beyond that is where we want to be, somewhere over here. Right, so here we have a 0 for the next bit. So I guess we can call this unused 1 and have that as a u1 to be 0. Let me just add a 0 here so we can know how many unused fields we have. Then we have DPL, which is the privilege level with 2 bits, and then the present flag, 1 bit, 1 boolean, I guess. Right, so privilege is a privilege level. We already have those, and I'm going to ring 0 as default. And then we have present, the present boolean, which is going to default to false. All right, so hopefully we did not get too sidetracked. I'm just going to set this to 0 and just going to set this to what index is 0. Sure. Lower offset set that to 0, and upper offset set that to 0 also. Cool. Right, so now let's actually take this here, put that there. We are going to change a few things. So here, the offset is actually something I want to rename. The offset refers to the address of the interrupt service routine, ISR. Are they going to talk about that here? I think not. Oh, there we go. There we go. So here we get to the IDT from the interrupt. We get the offset. To that, we basically use the correct segment that's been described in the IDT to run that. So, for example, if the interrupt happened in user land and our IDT asked us to run in ring 0, that means that we are going to make sure that this ISR here, given by this offset, gets ran in ring 0. Gets ran in ring 0 is what I was trying to say. And this offset here is basically to the base address given by the segment. And that means that we have this procedure here, this function, that basically gets ran by the CPU. And then we'll take a look at how the transfer happens. But first, the thing I want to do is, rather than offset, I'm going to call this ISR address. Well, you know what? Let's stick with the jargon they are using. Right. So here, let's think about how we want this. Okay. So I guess I could get rid of pretty much all of these, and we'll check as we go along. Right, so here, let me just go ahead and do limit becomes offset. No, never mind. Base becomes offset in here. So base becomes offset. There we go. So this should work nicely. Although this should become a U16, I believe. But let me just recheck the documentation here. Sure. Let's go to 64 bits. There we go. So offset, yeah, it's 16. And then we have selector. Cool. That's pretty nice. So we now have offset lower. That becomes offset lower. Sure. No, wait, hold on. Let's get rid of all of these. Next we have segment selector, and this one is just going to be a segment selector with so we need to know the index that we've used for GTT to set the kernel code segment. How do I go about this? Let's not get too sidetracked. Let's just go here, take a look at where we've created the code segment here. All right, so these two, we want them elsewhere. We want them somewhere global. Right, common.sig and go and paste those there. Let's define segment, I guess, is what we need to do. This one we import from types.zig .segment, and that should make this happy. Hopefully, no. Why is it not finding this? Types.zig. Is this not right? .segment. .segment. Okay. That's kind of scary. This one is public. It should just work. So why doesn't it work? Right. Right, let's actually do something here before we forget. Let's put these two as consts, and let's go to here. And I guess here we can do common dot this. Same goes here. Const common is at import common.sig. Okay. Now types, what is the problem here? Oh, right, okay. So that's the problem. And here we can just go ahead and do common dot, how do we call that? Code kernel, I forget. Common code segment selector. Let's prefix, actually let me just use the rename thing to prefix this with kernel. Same goes here, kernel. Right, let's see how much stuff we've broken. No, that's fine. So now if we go back here, so that's kernel, of course we need to import common, that's import common.zig, and that's all we need to do, I think. Right, and this is kernel code segment selector. And that should just work, I think. Right, okay, yep. So now that we have this, let's go ahead and do the other things. So we have IST. Honestly, let me just put this to 0. Do they start indexing with 1? Yeah, okay, but does it start at 0? Does it start at 1, buddy? Okay, so SS stable. I guess 0 is not really a value. Alright, I'm just reading this diagonally. I'm probably gonna get bit by this, but for now, let's move. Okay, so let's get rid of this and this. So now we have type, and this one is gate type. So this one we need to get as a parameter. So type is gate type. And this one would be args.type. Cool. And then here we have unused privilege, and then privilege is, I'm pretty sure that this would just be ring 0, so let's leave it as default. Present would be, I guess if we're creating it, it's so that it can be used, so let me just do that. And then offset upper is offset upper. And of course here we need to take, right, so I'll call this ISR, and I'll need a type for this. Can we do something like pub const ISR is a function that takes nothing and returns void? I guess that works, ISR. Right, so that's looks okay. And more than this, I'm going to need, so how do we do this? Call conv is naked. Yeah, without that. Right, so this will ensure that our function does not have any additional instructions in there. And so this is how we create the ISR itself. Now, if we go back to IDT, and here I'm just going to be very pragmatic and just go ahead and copy this and these, because we are going to pretty much reuse. So this one becomes IDT, this one has the same thing. This one becomes IDT, but this one we know that it's a segment.interrupt descriptor table. And I guess we can go ahead and call this max interrupt vectors. Yeah, and we can define those here. Max interrupt vectors is 256. This is a fixed value. Right, so now we can get rid of these. We can actually have this be, we can get rid of that. We can do max interrupt values, and we should know that this is a segment of interrupt table descriptors with an alignment of 1 page. So here I'm just going to get constants.arc page size, I think is what we call that. So constants is import constants, there we go. I'm just going to verify something. Yeah, that's a comp time int. Right, so here we want this to be a segment dot interrupt table descriptor. And here we need to create one. So set.mem.zeros of a type, which we'll call segment.interrupt table descriptors times max interrupt vectors. Yeah, and this one here becomes IDTR. Of course, should probably do GDT becomes IDT overall. The file, cool. So now with this, we should be ready to start working on our IDT. Right, so going back to GDT, I'm going to just take this function in it here. Although we are not going to initialize anything, I think we're just going to create the IDT and return it. Yeah, that sounds okay. Let's get that, go back here, put this over here, this returns self. This one here, let me just do that again. So GDT becomes IDT globally. And then I'm going to, I guess we could load it. Okay, so let's get rid of all of these. Let's get rid of all of these, and let's see here. So this one is initialized, this one has been initialized. And now I think, yeah, that looks okay. Looks good. It means that now we can go ahead and do function load IDR. IDT R IDTR. Okay, that's weird. Let me check how we called that in the GDT thing. GDT R. let's go. Okay, so this one here, I guess I'm just going to do pretty much the same. It's exactly the same thing. There's one character that's changing, which is this one here, as well as this one here, as well as this one here, and of course this one needs self, which is a pointer to self. We've created self up there, yes. And here we know that we don't have GDTR, we have IDTR, and I think I've messed things up. So this is IDTR. And yeah, okay, so well, kind of messed things up there. IDTR, so these ones become IDT, and this one becomes IDT. Sure. Okay, so there's no there's no flushing, there's no reason to flush the IDT. It's not cached, so it doesn't need to be flushed. And I guess we need to add a public function. And we'll call this register gate. Sure, that returns void. And this register gate should take a vector number, which is a U8, I think. Sure. And it takes an ISR, which should be of type ISR. We have that somewhere here. Otherwise, it should be segment.isr. Okay. And we also take self as a pointer to self, of course. And here we go self dot what did we call those things? Oh, nice. So IDT entries, entires. Okay, so IDT entries at vector, right? We know that this exists because reasons. And actually, I don't want to do this. I want to, let's think, I want to get a interrupt interrupt descriptor table. No. Wow. Okay, I'm getting a bit sidetracked here, but it's for the greater good. It's for the greater good. That's what I'm telling myself. Right, so I'm probably going to need to find a better name for this thing here. I'm not really satisfied with this because it's a descriptor that belongs in the global descriptor table, but that's kind of a bad name. So let me just call this global descriptor, and we'll call the other one a gate descriptor, and see how that fares. Yeah, let's call this one a gate descriptor. Sure. That means that now I can take this back here, put it into the gate descriptor, lose the gate from the type, and have this be type. Same goes here. And I could probably do the very same for this one here. descriptor type. I think this one is more generic. It's the other type, it's the segment type that I want to. No. That's fine. That's okay. So let's do this for now. Get that in there. Remove the descriptor from the name because we already know that it belongs here. Sure. Let's go with that. Hold on. Let's just do this this way. So this becomes type. And this, where was it? IDT. Okay, descriptor. This becomes type. That's fine. And this is fine. Okay. So this one here is not used, and it probably would never be. So for now, let me just comment this out. See if there are any other things that are broken. I guess this one is broken, so now this is called a gate descriptor. Same with this is a gate descriptor, and same with this, as well as this one here. Okay. This is broken because we don't have that anymore. We should probably just go ahead and do size of the segment gate descriptor times max interrupt vectors -1. And this one here would become just IDT entries. IDT entries. There we go. Right, so back to this. So gate descriptor, and this one here becomes a gate descriptor. Yeah, okay. So this one is gate descriptor, and that's that, I guess. Yeah. Okay, that's pretty cool. Okay, so I guess we build this and see. So make all. Very nice. Struct is has no member named global descriptor table. In GDT line 13. Right, so global descriptor is what we call this. Right, and we, okay. This one is hard, but not that hard. Let's go ahead and do this and do, no. Oops. No, let's do, oops, something like the const descriptor 16 bytes is just void. Okay, expected type but found void. Okay, how about this? Okay, that looks pretty good. Now, let's actually use our IDT in main, so that we are sure that, rather in here, not main. So var IDT is of type IDT, it's undefined to start with, and const IDT, oops, IDT is at import, parentheses and descriptors slash IDT.sig, something like this. IDT is .init, And this should load the IDT. And then here, I think we should be able to do IDT.setRegisterGate. So we want a vector. Let's go for, let's take a look at the vectors. It should be this chapter here, interrupts and interrupt vectors. Divide error. Sure, let's take the divide error and we'll see. Sure. So 0, and this one here needs to be some sort of function that takes dummy ISR, takes nothing, has a, let's forget the call convention for now. Let's pass it in here. So dummy ISR. And here it's ISR. Okay. Here it should say that backend integer type is has size 128, but the descriptor field has size 120. Really? How come? So 16. Oh. Okay. Segment selector is EU16. No, that's fine. We have 3 and 5. That's 1 byte. Type should be 4 bits. So 4 bits, 5, 6, and 7. No, 4 bits, 5, 6, 7, and 8. So that's those are 2 bytes. Those are 16 bytes. So we have 32 plus 16 is 48. And then we have 40, so that's 88. And then we have 32, so that's 120. What did we miss? What did we miss? 64-bit mode. So, 32, 64. And then the reserved is 32 bits. Is that right? This one is... Oh, yeah, okay. That's not good. That was not a great copy. Let me just recheck that our thing here has the correct layout. So 24, and the other one should be just is upper 8. Yeah, to make for 32. Right, so here what is the problem? The problem is expected type gate descriptor but found ISR. Yeah, of course. What am I even doing? So this one should be create of .isr is dummy ISR, I think is how this goes. And this create should link to the descriptor. Okay, maybe I should just create it here. So gate descriptor is of type segments. Segment gate descriptor. Yeah, I'll do something else. So IDT dot create IDT like so dot create. Oh, it's in it. It's in it. No, it is not. So const get descriptor. We need a p in there. Import descriptors types zig, and then we do segment.gate descriptor. Okay, so this one becomes gate descriptor dot create, I guess. Yes. Okay. This one here. Okay, so I guess this one just needs that to be happy. Didn't need to do all that, but okay. Right, so there we go. So the expected error is this one here. So it did catch the call convention that's not naked. Whoops, that's not what I wanted to do, but okay. So where were we? We were in descriptors IDT, I think. No, descriptors.zig. Yeah. Okay, so that's fixed. Let's see what the other issue is. Missing struct field type. Cool. So type is something, and I forget what type was actually. Hold on. Type is type, and type is gate type, and this should be interrupt or gate. Right, so going back to where we were here. So this one is an interrupt, I guess. Yeah. All right, so let's pass type as interrupt, and we are good to go. So this one here is gate descriptor.type. Or I guess I could just go for interrupt gate. Okay, so it has no tag with value 0, so we can't create it with zeros like we did in IDT. How do we go about those? Sure. I guess that's something I could do. No field named offset. Where is that? That's in 121. Oh. Okay. All right. So const offset is int from pointer of args dot isr, and here we go offset, and then here we go offset again. This one becomes 16, of course, otherwise we'll have a problem. And it does build. Cool. QEMU, let's remove the debug stuff and go. We should have nothing happen, and nothing has happened. Cool. The reason why nothing has happened yet is we have not yet enabled interrupts. We have set the IDT. We have created this gate here. We'll see if it was correctly created when we debug this, but we still have not registered any interrupt handlers. We still haven't done the interrupt handling correctly, because this is not, in fact, I think this is disallowed. this is not a valid interrupt handler. If we get an interrupt and we run dummy ISR, it's going to panic because we don't. This function here has a ret at the end of it, and we want this function to end with an iret, as well as do some do stack magic. And the stack magic that we need to do is described by some of the diagrams that we so kindly get from, there we go, so kindly get from Intel. Do we have the diagram for 64 bits? Yes, there we go. So we, after the exception or the trap, we get, when the handler, the ISR is run, it gets a, on the ICE T on the stack table, or on the stack that's getting chosen from the stack table, we get some data in there that we need to use and or handle before we return from the stack, from that interrupt, basically. Right, but that's a problem for future me. Well, that's pretty much it for this video. As always, if you've liked it, hit like. If you're not subscribed, please subscribe. And if you have questions or comments, please leave them down below. We have worked on or started work, I guess, on the IDT. We still need to validate that it works, and we still need to go on and do the interrupt stuff. Yeah, so we do have our work cut out for us, but we are making good progress. Anyhow, until next time, I'll see ya. Fucking out.